Hi everyone, welcome back. We're going to go through another question from North London Collegiate School. And so we're going to jump onto my whiteboard or my iPad and go through two questions from this paper. Now, the first question is quite a simple one, but I know that a lot of children struggle algebraically, so let's see what we can do with this. It says another question goes on to say he holds up a third card. He says if I subtract this number from 50, so I don't know what the card is, right? So a third card, we don't know what this card is, so we're going to call that X, okay, because we don't know what it is. It could be anything, it could be a blank square, for example. That's also fine. But it says if I subtract this number from 50, so I've got 50, I'm subtracting that number from 50. That means I'm going to subtract that number. I don't know what it is. I'm going to put a box, or you can put an X or whatever you want, and then I halve it. So I'm going to halve all of that. That gives me 19. So I have something like this. Something take away 50 take away something divided by 2 gives me 19. So before I divided by 2, it must have been double 19, which is 38. So this part here, just this section here, let me shade that in blue, just that section there must give me 38, because I know 38 divided by 2 gives me 19, right? And so that number, unknown number, is just going to be 50 take away 38, which is going to be 12. And so I've got 12 here, because 50 take away 12 must be 38. 38 divided by 2 is 19. So we can look at it in this non-algebraic way. We have to use our reasoning skills. But using algebra, we can just write 50 take away x over 2 divided by 2 equals 19. And now because I divided everything on the left hand side by 2, I'm going to multiply everything on the left hand side by 2 to remove this dividing by 2. Right, because anything we double after halving is going to be back to whatever we had, right? And so that's why they cancel each other out. But remember, whatever we do on the left hand side, we have to do on the right hand side. And so 19 times 2 is 38. So we have something like 50 take away x equals 19 times 2 is 38 is 38. So 50 take away something gives me 38. I know that something is going to be 12. But we can use algebra to solve this in a more algebraic fashion. We can subtract 50 if we wanted to, or we can add x on both sides, and we get 50 is equal to 38 add x. And again, I can think of what number added to 38 gives me 50. That's 12. But again, we can go into it more algebraically. We can subtract 38 on both sides, and we're left with x is equal to 12, or in this case the number is equal to 12. And so that's another way of looking at this question more algebraically. We can do it non-algebraically using reasoning skills, but we have to understand what it says. When it says if I subtract this number from 50, that means I start off with 50 and I'm subtracting whatever number it is from 50, right? So I start off with 50 and subtract it from there. The second question here can be challenging if we think of it just using algebra. Reasoning skills can be a bit easier. Sometimes algebra for some students can be easy as well for this one. So he holds up a fourth card. He says, if I multiply the number on this card by itself. So I don't know that number, right? So fourth card, I don't know. But if I multiply it by itself, that's the tricky part here. If I use a box, I don't know, like, how do I show multiply by? I could do this, but that could mean any number, right? It could be 5 and 4, but that doesn't mean multiply by itself. So in this case, I might write x times x. Now, before I think about anything else, multiplying by itself gives me a specific type of number, right? Do you know what type of number it gives me? Anything multiplied by itself gives me a square number, right? So I know when I multiply anything by itself, 5 times 5 is 25. 25 is a square number. 6 times 6 is 36. 36 is a square number. 10 times 10 is 100. 100 is a square number. So anytime I multiply anything by itself, it's going to be a square number. And so I know this initial part just tells me that I've got a square number. And then when I subtract this result from 100, so the key word there we have to look out for is the word from. From 100 means I start off with 100 and I subtract this square number, and that gives me 36, right? So I know that what number take away from 100, if I take it away from 100, gives me 36. This part must be 64, because 100 take away 64 gives me 36. So that fourth card must be a square number, which is 64. I'm right. And then what number multiplied by itself gives me 64? It must be 8, right? 8 times 8 gives me 64. 8 times 8 is 64, and therefore 100 take away 64 is 36, and I get the number that I've been looking for. This on this card, it must be an 8, because only way we can get 36 after multiplying the number by itself, 64, and taking away from 100 take away 64 is 36. Yeah, it must be 8. Does that make sense? So even though I've written X here, which is algebra, right? What I'm just trying to do is I'm only writing that there to make me realize that X times X must be a square number, right? X times X is actually, algebraically, we write that as X squared, right? Which just means that I'm going to get a square number here. I have a square number here. And so for us, we can think of it in a slightly less algebraic way and understand that when I multiply anything by itself, it's a square number. So I can take it from there. 100 take away a square number gives me 36. That square number must be 64. That means that number must have been 8, because 8 times 8 is 64. Hope that made sense to you, and I'll see you in the next video. Bye.